Hello and good day to you. So I'm trying to get a bit better on my networking. Networking has always been something that I have done training on and never really applied. So I'm trying to change that by doing some exercises, and the first one is to do a slide deck on how TCP networking works, and then move on to some Python programming, which will come in later videos. TCP stands for Transmission Control Protocol. TCP is a standard that dictates how to establish and maintain a connection between two computers that can then exchange data. I like to think about TCP as it's the equivalent of a computer contacting the other computer, using its IP address to know which computer to contact, setting up a handshake and introducing themselves, and setting up a conversation before continuing with the conversation. So what happens with the TCP is you establish a connection between two computers for them to be ongoing communication. In contrast to this, you have the user datagram protocol, which is just for sending individual packets or bursts of packets. With UDP, we're not interested whether there was a setup for the conversation, and in fact, if you use a UDP and the other computer wasn't expecting it or doesn't know what you're on about, it will just get ignored and discarded. The reason we use this for is it's good for games where speed is essential. We don't have to set up a conversation, we don't have to maintain the connection between these two computers. And in games, genuinely, security is not important. Nobody really cares about how much ammo is in your gun in Counter-Strike. Nobody's going to hack into your connection to try and reroute that piece of data. And if they do, well, that's a bit sad. The other thing, the reason it's good for games is if you're sending this packet of information every single frame for the computer game, you want the speed. You don't want to be bogged down with setting up that connection, maintaining that connection, all that irrelevant stuff. And if you're actually going to be setting up security of any type, you probably have already done it in how you programmed up the computer game. TCP, on the other hand, is a reliable protocol. TCP uses a checksum to confirm everything has arrived in the right order. So every packet that it sends has a rubber stamp sequence number, and that if the receiving computer receives things in the wrong order, it will do the wrong checksum calculation, respond with the wrong checksum, which will tell the sending computer that it needs to resend and reset up the communication. So TCP will keep on resending, and will do this without the programmer's interaction until the data that was sent is received in the right order. Obviously, this is very useful when you want to send files to confirm that that Word document you're sending was all received correctly, and to get that final confirmation. Security is a major issue. Any information you send over the internet will be sent through various different routers, and if that data was sent wrongly, passed over a compromised router, or a malicious actor has already taken actions to do various things which are outside the scope of this video, you could end up with either them reading your data, which is a bit problematic if the data you're sending is, you say your credit card details, or they could end up taking your data, rerouting it you by spoofing the conversation. Now, I've used metaphors so far for TCP as it's a lot like walking up and having a handshake and setting a conversation. Well, one was if when you walked up, you got rerouted and ended up talking to the wrong person, mistaken identity, and that other person pretended to be the person you think you should be talking to. That's the sort of metaphor we need to think about when we're thinking about the insecurity of these apps. To provide security, TCP comes with SSL and TLS. SSL stands for Secure Socket Layer. TLS stands for Transport Layer Security. SSL, which I'll get to next, is usually added on top of TCP, so it's a separate part. TLS is embedded usually within the TCP protocol, or what they would call the stack of the different steps within the protocol to set up that transaction. SSL in short is confirms and authenticates the server you contact is the right server. TLS is just about encryption. So again, going back to metaphors, TLS is much like when you've walked up to the person you've chosen, you've set up your handshake, you've agreed the encryption, and then moving forward in the conversation, TLS will mean that that conversation is encrypted, which makes it very hard for a bad actor to get in between that conversation and disrupt it after it's been set up. TLS does nothing to confirm that the person that you're talking to is who they say they are, metaphorically. SSL is about confirming the person you're talking to is the right person. It does this with the certificate authorities. Certificate authorities are various internet websites, IP connections, which you will connect to first, confirm that you're connecting to the right place, and will authenticate the certificate for the computer that you're connecting to is trustworthy. So for people who've never encountered this idea, it's almost like you go to a website for Amazon and somebody like Windows says, yes, that's definitely Amazon. You haven't gone to the wrong app at the wrong place. So continuing our metaphors, because I like metaphors, this is a lot like you being introduced by a third party. Now, how do you know you're getting to the right place? Computers deal with numbers, and these numbers we call for addresses as IP numbers. An example would be 65215.221.149, and that's 4 bytes. And that's the standard for IP version 4, which allows for that big number starting with a 4 in the middle of that slide, which I'm not going to try and go through. I feel that the IP version 4 was very badly allocated, which is one of the reasons we're now on IP version 6, which is now 2 to the power of 128 different values that can be connected. Now, that means we've got enough for the Internet of Things, which will be sort of like connecting even things like your toaster to the internet, if you wanted to. IP addresses are the numbers that stand behind website addresses. So when you look up a website address, you type it into your browser will go to a DNS server, ask it, what is this string that I've got? The DNS server will look down its table, either reroute you to a different DNS server if it doesn't know, or confirm back to you the right IP address, which you can then get to the website you're trying to go for. Now, there's a whole additional bunch of stuff with address masking and subnetworks, which I'm not going to go into. They could be several videos in themselves. When you've set up a TCP connection between two computers, you're going to use a port. Now, the great way to think about ports is to think of it as what would happen if I didn't have a port. Now, if you didn't have a port, you'd send a message to the computer. That computer would get that message and would have to look at every program running on the CPU and contact every single one and check every single one to say, does this mean anything to you? Which every single of those programs would have to do some diagnostics and check to see whether that message meant something to them. That's clearly not very useful. So a simple way of getting around this is we have ports which are set up and opened and closed on computers. If you send data to a closed port, it's probably going to be discarded. The computer's going to receive it and just do nothing with it. If you send it to the right port, that will allow the CPU running on that computer to take that message and pass it on to the right application that will need to receive and act on it. So for most web servers, it's typically listening on port 80. You send to port 80 and that web server sends you the website back as a set of data. And that's it for my my stack of that's it for my presentation. Something that I'm still trying to get into. I've done lessons on it previously, and it's never really stuck in terms of me walking away and going and setting up my own Wi-Fi or my own website. I think I need to correct that. Now, I think I've always found that these sort of network programming stuff is actually a lot more simple than people think it is, but it's when you get really into the details that you can get absolutely lost. And understanding the complexities of how router algorithms run is just its whole own speciality. But hopefully in the course of these videos I might be able to put together something that makes some of those things just a little bit more easy to understand for you. If you have any questions or any pointers, please let me know. Thanks, have a good day and a good night. Bye.